In this video, we'll learn to efficiently handle multiple form inputs using the computed name syntax. Additionally, we'll also learn and implement debouncing to optimize form handler functions, especially if it leads to frequent API calls. Let's begin. We've been playing with form elements in this section, and I'm confident that by now you're well equipped to incorporate form elements in your React apps. In this video, however, we'll discuss two techniques that can go a long way in optimizing form elements and how you use them. This is important because performance is key, and so is maintainable code. Our first case study deals with handling multiple input elements. You will often come across situations where several form elements need to update respective properties in the state. Naturally, this calls for the use of multiple event handlers. But can this process be made more efficient? Let's find out. Begin by downloading, extracting, and setting up the project first. Our app component here renders a form with multiple input fields that update the state. The section at the bottom of the UI dynamically renders the contents of our state properties, as you can see. All form elements in this example are controlled elements, so they update the state, which in turn updates the form elements so they remain in sync. Here's the state object containing various properties that are updated using the form. At this point, every form field implements an onChange event handler function that individually invokes this.setState, which is hard-coded to update their respective state properties. In the case of our checkbox group, we have to update a subproperty from the privileges object in the state. Hence, we are using object spread to easily update respective properties. But this is still manually handled here, individually in all form elements. As you can imagine, this is prone to errors, is not maintainable, and is certainly not the most efficient way to handle this form. Almost everything is hard-coded, and this must be prevented as much as possible. To optimize this application, what we should ideally do is build a single event handler function that caters to all form elements without the need to hard-code individual event handlers for every single form element. I'll thus begin by creating a function called formHandler, which will bring in the event object that the onChange event listener shall provide. Out of this event object, we are interested in the event.target property, which is all we need to bring in data associated with the form element. I'll thus destructure and extract the target property directly, as you can see here. We'll then replace individual event handlers with reference to our central form handler function, like so. An important requirement for this technique is the mandatory presence of the name attribute on every form element. This name should exactly reflect its equivalent state property and is case sensitive. Now, whenever a user types in these input fields or checks one of these boxes or radio buttons, the target property in our form handler function provides access to three important properties. The name property provides access to the value of the name attribute on the form element. The type tells us whether it is a text field or a checkbox or a radio button, and the value gets us the value that the user has typed in, or the value set for a checkbox or a radio button. Once we have these, we can run a singular instance of this.setState where we'll dynamically set the name of the state property to update using the computed property name syntax, which is an ES6 feature. We can then set it to the value, and this is all we categorically need to do. For every invocation of the form handler function, we get the name of the state property to update using the name property, and we get the value. There's just one tiny problem that we need to address here. Our privileges checkbox group has respective state properties that are set to true or false based on the user's choices. Since all three checkboxes belong to the same and common name privileges, how exactly do we toggle the author, moderator, and reviewer subproperties here? To implement this feature, we'll use a ternary expression to test if you're dealing with a checkbox or not. This can be done by testing the value of the type property. If so, we'll use a combination of object spread and computed property name syntax to selectively toggle the value of the properties like so. If you're not dealing with a checkbox, we'll simply use the value as is. And this is all the code you need to replace individual event handlers as we had before. This will even work if you add more form fields here. Now, before we end this example, let me ask you this. Can you replace individual on-change event listener expressions with just one for this entire form? Let me give you a hint. All events bubble up. As you saw in this example, by writing a single and central event handler function, you can greatly optimize a React component and streamline the process of handling multiple input fields. This brings us to the second part of this video. Imagine you've built a search component that is required to run a query against a database or an API as you're typing in. The default behavior in this case is that our queries are run every single time the user types in the form field. This is because the onChange event listener executes the event handler function at every single change to the input field's contents. As you can imagine, this isn't efficient because you're literally going to bombard your API or database search with queries. If your API is rate limited, as it should be the case to prevent denial of service attacks, you may easily reach the threshold if you fire off a query for every single character that the user types or deletes in an input field. To solve this problem, we should use debouncing. In simple words, debouncing is the process of delaying a function. We let the users type and we wait for them to stop typing until a given duration has elapsed before we execute our API call. This brings down the number of requests. Technically speaking, debouncing works by initializing a timer every time an event is received. Let's say we want to delay the function by 400 milliseconds. As the user types in, at every invocation of the onChange event handler function, our timer would be reset and set to count up to 400 milliseconds. Assuming the user types in at a standard rate of about 190 characters per minute or so, our timer won't be able to reach the 400 millisecond threshold easily and would keep resetting back to 0. That is until the user stops typing. This is when the timer reaches its mark and executes our API call. Even if the user types slowly, this process can considerably bring down the number of API calls. Let's implement debouncing in an example. Download and set up the example project first and kickstart the development server. Our little app features a search mechanism that crawls through a static collection of books that is bundled with the project. As the user types in, the collection is searched and the results are stored in the results array in the state. This is displayed as a list of book titles. If the user clicks on title, its database entry is fetched and stored in the selected book property in the state. The heart of this app is the search books function, which accepts a keyword, performs a search, and populates the results array in the state. At this point in time, this function is executed using the onChange event listener. This means that our search function is executed every time a character is typed or erased in the input field. Let me demonstrate. I'll type Java and you can see the result from our search in a drop-down list that is rendered on the UI. You can also see the number of times the search function ran, which in this case was once per character typed. Take a look again. This time I'll type Microsoft and our search function runs 9 times. Imagine if these were individual network requests to your search API and multiply this by the number of users and you have a rather uncomfortable number of calls to the API. Let's quickly implement debouncing to prevent such a situation. The fastest and most practical way to implement debouncing is by using the popular Lodash utility library. Here's the documentation for the Lodash library, and we can find the debounce utility function in the function category like so. As it says here, and I quote, "This function creates a debounced function that delays invoking function until after wait milliseconds have elapsed since the last time the debounced function was invoked." But how do we use this in our React component? To begin with, I'll bring up another terminal in my app folder and we'll run npmi lodash.bounce to specifically install the debounce function instead of the entire Lodash library. It is important to note here that when working with React apps, the final production bundle needs to be as concise and small as possible. When working with third-party modules and libraries, it is important to pay attention to the size of the package being used to prevent heavy production bundles at the end. When working with collections of modules such as the Lodash library here, we have chosen to install the debounce function specifically rather than the entire Lodash library, which is the usual convention and practice. This helps us keep our production bundles small at the end. Once npm finishes downloading and installing the function package, import it into the app.js file using an import statement like so. Then all we need to do is grab this anonymous function part of the search books function and wrap it in an invocation of the debounce function as the first argument. The second argument here will be the wait milliseconds or the delay that we need to introduce here. I'll set this to 400 milliseconds. Let's test this now. I'll type Java persistence as the search key, and since I was fast enough, the search books function only ran once instead of 16 times as would have been the case without the debounce function. Next, I'll type the word Microsoft slowly, and this time too we just got 2 invocations of our search function instead of 9. As you saw in this example, debouncing a function can drastically cut down the number of invocations, especially in cases where the functions lead to API calls that may be rate limited. While debouncing can also be natively implemented using setTimeout, the fastest way in production is by using the debounce function from the popular Lodash library. In the next and last video in this module, we'll go all hands on deck and build